Welcome to Drop Knowledge. Today, we're going to talk about audio amplifiers. An audio amplifier is a device that boosts the audio signal from the head unit or source unit to a higher volume so that it can drive the speakers or the subwoofers in your audio system. In this video, I'm going to explain the basics of how an audio amplifier works. The basic principle of an audio amplifier is to use a small input signal to control a larger output signal. This is achieved by using electric components called transistors, which can act as switches or variable resistors. A transistor has three terminals: the base, the collector, and the emitter. By applying a small voltage to the base, we can control the current flow between the collector and the emitter. The input signal is connected to the base and the output signal is taken from the collector. The emitter is usually connected to the ground or to a negative voltage source. There are different ways to connect the transistors to the input and output signals, and these are called the amplifier classes. The most common classes are Class A, Class B, Class AB, and Class D. Each class has its own advantages and disadvantages in terms of sound quality, efficiency, and complexity. Class A amplifiers are the simplest and most linear, but also the most inefficient and wasteful. In a Class A amplifier, the transistor is based in the middle of its active region so that it conducts for the entire cycle of the input signal. This means that the output signal is an exact replica of the input signal, but amplified. However, this also means that the transistor is always on and dissipates a lot of heat and power. Class B amplifiers are more efficient but less linear. In a Class B amplifier, the transistor is based at the edge of its active region so that it conducts only for half of the cycle of the input signal. This means that the output signal is a clipped version of the input signal with only the positive or negative half. To get the full output signal, we need two transistors, one for each half, and combine them using a transformer or a capacitor. This is called a push-pull configuration. However, this also introduces a problem called crossover distortion, which is a gap or a spike in the output signal when the transistors switch from on to off or vice versa. Class AB amplifiers are a compromise between Class A and Class B. In a Class AB amplifier, the transistor is based slightly above the edge of its active region so that it conducts for more than half, but less than the entire cycle of the input cycle. This means that the output signal is closer to the input signal, but still clipped. However, this also reduces the crossover distortion and improves the sound quality and efficiency. Class D amplifiers are the most efficient, but also the most complex. In a Class D amplifier, the transistor is based either fully on or fully off so that it acts as a switch. The input signal is converted into a pulse width modulated signal, which is a square wave with a variable duty cycle. The duty cycle is proportional to the amplitude accordingly. The output signal is then filtered to remove the high frequency components and recover the original signal. This means that the output signal is a smooth version of the input signal, but amplified. However, this also introduces some challenges, such as switching noise, electromagnetic interference, and filter design. But besides the amplifier classes, there are other features and specifications that you need to consider when choosing an audio amplifier. Some of the most important ones are the number of channels, the amount of power, what the impedance of your subwoofers might be. So let's take a closer look. The number of channels in an audio amplifier determines how many speakers or subwoofers it can power. A single channel amplifier, also known as a mono amplifier, can power one speaker or subwoofer. A two-channel amplifier can power two speakers or two subwoofers, or one speaker and one subwoofer in a bridged mode. A four-channel amplifier can power four speakers or subwoofers, or two speakers and two subwoofers in a bridged mode. A five-channel amplifier can power four speakers and a subwoofer, or two speakers and three subwoofers in a bridged mode. A six-channel amplifier can power six speakers or subs, or three speakers and three subs in a bridged mode. The power of an amplifier is measured in wattage, and it indicates how much power it can deliver to the speakers or subwoofers. The power rating of an amplifier can be given in two ways: RMS power and peak power. RMS stands for root mean square, and it represents the average or continuous power that an amplifier can produce. Peak power, also known as max power, represents the maximum or burst power that an amplifier can produce for a short period of time. RMS power is more reliable and realistic than peak power, and it should match or exceed the RMS rating of the speakers or subwoofers that you are wanting to connect to the amplifier. The impedance of an amplifier is measured in ohms, and it indicates the resistance to the current flow that the amplifier can handle. The impedance rating of an amplifier can be given in two ways: nominal and minimal. Nominal impedance is the standard or typical impedance that the amplifier can operate at. Minimum impedance is the lowest impedance that the amplifier can operate at without overheating or damaging itself. The impedance rating of an amplifier should match or be higher than the impedance rating of the speaker or subwoofer that you're connecting to the amplifier. The sensitivity of an amplifier is measured in volts, and it indicates how much input signal voltage the amplifier needs to produce its rated power output. The sensitivity rating of an amplifier can be given in two ways: high level and low level. High level sensitivity, also known as speaker level sensitivity, is the input signal voltage that the amplifier needs when it is connected to the speaker wires of the head unit or source unit. Low-level sensitivity, also known as line-level sensitivity, is the input signal voltage that an amplifier needs when it is connected to the RCA outputs of the head unit or the source unit. The sensitivity rating of an amplifier should match or be lower than the output signal voltage of the head unit or source unit that you are connecting to the amplifier. The signal-to-noise ratio of an amplifier is measured in decibels, and it indicates how much noise the amplifier adds to the output signal. The signal-to-noise ratio of an amplifier can be given in two ways: weighted and unweighted. Weighted signal-to-noise ratio, also known as A weighted signal-to-noise ratio, is the signal-to-noise ratio that is measured using a filter that mimics a human hearing response. Unweighted signal-to-noise ratio, also known as flat signal-to-noise ratio, is the signal-to-noise ratio that is measured without any filter. Weighted signal-to-noise ratio is more relevant and realistic than unweighted signal-to-noise ratio, and it should be as high as possible, preferably above 90 decibels. So there you have it. These are the basics of how an audio amplifier works. Stay tuned and don't forget to like, share, and subscribe. Thanks for watching. Thanks for watching. Thanks for watching. Thanks for watching.
Thanks for watching. Watching.